Async and await helps us write asynchronous promise-based code in a way that reads and behaves similar to synchronous code. Async await is a relatively new addition to JavaScript, which allows us to wait for a promise to complete before moving on to the next line of a function. In this tutorial, we'll learn what the async and await keywords do. We'll learn how to use async and await to work with promises. We'll also learn how to handle errors when using async and await and how it differs from working with regular promises. Async await is a JavaScript feature that was first added to Node.js in version 7.6, so it's been around since about 2017. At its heart, async await allows us to write asynchronous code that looks and behaves like synchronous code. What that ultimately means is that when you're using async and await, the await keyword will allow a function body to pause its execution and come back to that part of the function when the promise or asynchronous work has completed. Overall, async await can greatly simplify working with promises. It allows us to write less code when working with promises, which gives us the benefit of more straightforward, easier to work with code. Here's an example of what happens when you make synchronous code with promises. We're using the node-fetch npm package to make a request to the JSON placeholder API. If you're already familiar with promises, you should know exactly what happens once we run this file. The console log on line 8 runs before the promise finishes and logs out the response status. If we wanted to log the word complete with the response status, we'd have to move the console.log from line 8 into the then handler from the promise. Now let's rewrite this code with async await. With async await, we don't have to nest the console.log inside of then handler to wait for the promise to complete before logging out the data. Instead, we create an async function and inside of it use the await keyword to pause the execution of the function until the promise has completed. And then when the function resumes running, our res variable will have the resolved value of the fetch promise, which allows us to then use that variable on the next line with the synchronous console.log. So let's talk a little bit about what happened there and how we were able to do that. Let's start with the async keyword. Await needs to be used inside of an async function. We create an async function by prefixing the function with the async keyword when we're creating the function. This does something special to the function. An async function will always return a promise. Even if you return a regular value from an async function, that value will be wrapped in a promise. And this is an important point, so I'm going to repeat it again, but you can only use await inside of async functions. There's something called top-level await, which will be coming to Node and JS eventually, but right now you can only use the await operator inside of async functions. If you try to use await in a regular function, you'll get an error. The await operator is something you put in front of a promise or a function that returns a promise. It allows you to wait for a promise to resolve. When you use the await operator on a promise, it will return the resolved value of the promise. That's what allows you to assign a variable on the left-hand side when you're using await. The value of that variable will be whatever the promise has resolved. If the promise doesn't resolve anything, then the value will be undefined. When you call await in the body of an asynchronous function, the function will pause its execution until the promise resolves. So that means that no more of that function will run until the promise is finished. It pauses the function in a non-blocking way. Other parts of your code are still able to run while this function has been paused. Finally, if you're awaiting a promise and that promise rejects, the error will be thrown. Because await can throw errors like that, it means that we need to have a strategy to catch them. Handling errors is a little bit different with async await than it is with promises, so that's what we're going to cover next. When working with async await, you have two main options for error handling. You can handle errors thrown by await by wrapping the await calls in a try-catch block. This is typically the standard way to catch errors that are thrown with either a throw statement or that are thrown by a synchronous function throwing an error. Your second option is to attach a catch handler when calling the async function itself. All async functions return a promise, and if an error is thrown inside of an async function and not caught somewhere by a try-catch block, that error will bubble up to the async function itself, at which point it can be caught by a catch handler attached directly to the async function when it's called. Error handling with async await can feel a little bit awkward because you're usually wrapping things in try-catch blocks. But in Node.js version 12 and higher, async await has better stack traces for errors than just using promises. So there are actually some benefits from the standpoint of error handling when using async and await. Unhandled promise rejections and thrown errors can crash your application. So when you're using async and await, make sure that you're using one of these methods to catch your errors. Let's add some error handling to this example code we were working with earlier. Our first option is to wrap the await call itself in a try-catch block. Wrapping the await call in try catch allows you to handle the error where it occurred. In this case, we're just logging the error to the console, but if you wanted to retry the request or handle the error in some other way, you could do that in the catch block inside of the run function itself. The other approach to catching errors when using async await is to add a catch block when calling the run function. This approach allows us to handle the error outside of the async function. This can be really useful if you want the error to be handled by some logic that exists outside of the function where the error occurred. Handling an error in place like we did originally with the try catch blocks is probably the more common way to handle your errors, but it's definitely not the only option you have with async and await. To recap, we learned that using the async keyword when declaring a function makes that function always return a promise. And we learned that await will pause the execution of an async function to wait for a promise to resolve. We learned how to use async and await together to work with promises as if they were synchronous code. And we also learned how to handle errors when using async await by either using a try catch block around the await call or by putting a catch handler on the end of an async function when calling it.